Today we continue our talk about circles. Okay, as we said, for each circle we have the standard form of its equation, which is x minus the x's of the center squared plus y minus k, which is the y of the center squared equals the radius squared. But sometimes we have a question. In this question we don't have the standard form of the circle, so we have to transfer this form into the standard form. Normally we are given an equation like this form: x squared plus y squared plus some terms with x and y and some constants. So what we have to do is we have to, as we said, group these x and y's and then move this constant or these constants to the other side, and the most important step, which is complete the square of 4x and y. So we have to transfer each one of these squared into parentheses squared, and then the last step we will put these into standard form. What we did in this example, we have this formula or this equation. The first step was we grouped the x and y together, so we got x squared plus minus these 4 and this y squared with the 8, and we moved this negative 11 to the other side to do the perfect square. And then we said we add a number. This number is half of this number divided by 2 and squared. So why it's 4? Because 4 over 2 squared we get 4, and why it's 16? Because 8 divided by 2 is 4 and 4 squared is 16. And then we have this equation. To transfer this into the standard form, we take these terms together to get this parenthesis and the y together to get the parenthesis, and we have the radius, which is in this case 9. So for this equation we have the center and we have the radius. So this is how we transfer the normal equation into a standard form equation of a circle, to find the radius and to find the center of this circle. So basically it's one step. We just need to complete the perfect square to get the parentheses, and this is a very important question when it comes to a SAT exam. We took also another example when we had, instead of 1 as a coefficient of x squared and y squared, we have 4. So basically after grouping these terms together, we have to take this 4 outside the parentheses. This is why do we have to do this? Because at the last step we have to divide by this 4 to get rid of this 4. This is what we did. We grouped the terms together, and then we have to add this, let me say the magic number, which is half of this number squared for both sides. We noticed that in this case x is plus 0, so we don't have to add anything. So we added this number to both sides, and then after having this 4 outside the parentheses, we have to divide by this 4 to get the final standard form of the circle, which is in this case x squared plus y 9 over 2 squared equals 19. Okay guys, after speaking about circles and the standard form of circles, and we said that for each circle we can have the center and the radius of this circle. So now we will talk about a new definition related to the circle, which is the tangent of a circle. So by definition, if you want to define a line which is tangent line of a circle in some point, we can define the tangent to a circle at one point as the line which is perpendicular to the radius of this circle, which is perpendicular to the line between the center and this point. So basically in this figure AB, we call this the tangent of the circle in the point or at the point D with the radius R. So to define a tangent, we need to find the line which is perpendicular to the radius of this line at this point D. How many tangents do we have for a circle? We have infinite number of tangents, because in each point we can define a new line with a new slope with a new equation. So how to find this tangent? First we have to define or determine these 2 points, the center of the circle and the intersection point between the tangent and the radius. Once we have these 2 points ready, so we can start finding the tangent. And then after finding these 2 points, we have to find the slope of this line. So normally how to find the slope of this line, we need 2 points. So we know that these 2 lines are perpendicular. So what I can do is I can take the slope of this line and take the reciprocal of this line, which is the slope of this line. Because as you know guys, if we have 2 perpendicular lines, AB in this case and DC in this case, so the slope of one of them is or equals to negative the reciprocal of the other one. So immediately you take the slope of this line, you multiply by negative, you flip the slope. How to find the slope of this line? Basically we have 2 points, so immediately we can find the slope by using the formula y2 minus y1 over x2 minus x1. Let's take an example to show the process or the operation of how to find the tangent of a circle. Okay, in this example he's asking me to write the equation of a line, the tangent to a circle. The equation of this circle is x squared plus y squared equal 29 at the point 2, 5. So this point, imagine this point is D, and the center of this point of this circle is 0, 0, because this equation has a center of 0, 0, while the radius of this circle is radical 29. So I have to find the tangent of this circle. So first of all what I have to do is I have to find the slope of this line, which is the radius. How? We have 2 points, the center which is 0, 0, and we have D which is 2, 5. So immediately I can find the slope by using the formula as we said, 5 minus 0, 2 minus 0, so the slope would be m equals 5 over 2. So guys, this slope is the slope of this line, which is the radius in this case. So I need to find the slope of the other line, which is the perpendicular line AB. So I have to take this, multiply this by negative, and flip this slope. So if we took this slope, we multiply this by negative, and we flip this, we will get the slope of the tangent, which is negative 2 over 5. So the slope of this line is negative 2 over 5. So now we need to find the equation of this tangent. As we know, we can use the standard form of the line's equation, which is y minus y1 equals mx minus x1. But I need m, I need y1, I need x1. I can use this 2, 5 as a point x1 and y1. So instead of y1 I have 5, instead of x1 I have 2, and instead of the slope I have negative 2 over 5 because I already found this. So basically this is the equation of the tangent of this circle. You can simplify this equation to get a simplified form, but guys, what we found is the equation of the tangent of this circle at this point, which is 2, 5. We found the slope, of the perpendicular line, and then we used the standard form of the line's equation to find the equation. Thank you guys, hope you enjoyed the class.